everyone is doing well and looking forward to vacation, I'm sure. I'm looking forward to seeing everyone in the new year. We have one section we're doing this week. You started to do it by doing a discovery yesterday, and hopefully you came up with this big idea. Lines are parallel if they have the same slope or equal slope. So that's going to become important when we want to write an equation of a line that's parallel to a given line, or if we want to figure out if two lines are parallel without even graphing them, just by looking at the slope. Okay. And so we're going to take a look at lesson 1. So you should have this handout right here. Okay, and we're going to fill in these notes right now. Okay. So, big idea. Lines are parallel if they have the same slope. So fill that in. And then I'm going to go through a couple of exercises with you so that you can practice this today. Okay. So, we've got an example here, example 1. Because write an equation in slope-intercept form for the line that passes through the given point and is parallel to the graph of this equation. And they're telling me what the line is. So really they just had to give me the equation. But I want us to also draw the line. So we have an example done out for us right here that we could follow, an exemplar. But I'm obviously going to bring you through this, right? The first thing to do is to recognize what is the slope of the line they give you. That's the only information you need from that equation. And ideally, it's going to be in that nice form, y equals mx plus b, so we can just identify what the slope is. The slope is the coefficient of x in slope-intercept form. And so we can see that the slope here is 1. So if the slope of this line is 1, then the slope of the line through the other point is going to also be 1 because they have the same slope. So now this becomes a problem that we did in previous sections, actually the last section, where they're asking you to find the equation of a line with the given slope and the given point. And they want it in slope-intercept form. So we know that we can't start with slope-intercept form, okay, but this is my goal. Okay. Owen, can you let Mojo out? So we're going to use this information and we want to get an equation in this form. But we need to start with point slope form. Remember, we always start with point slope form. So we've got y minus y1 equals m times x minus x1. And so we plug in our point, y minus 1 equals m times x minus 5. And so we distribute, which is really easy because it's just 1, and then we bring the constant over to the other side because we want it in y equals mx plus b form. And there you go. The equation of that line is, I don't know if you can see it, y equals x minus 4. Oop, can't quite see it. Let me back that up a little bit. Y equals x minus 4, so you can see all the work there. Okay? All right, so the steps are figure out what the slope is of the line they give you, and using the point, find the equation like we did in the last section. Now they also wanted us to graph this, and so we could certainly graph it. We didn't need to find the equation to graph it because we have the point and we have the slope, so we know it's going to be up 1 over 1. But if we do graph that, right, with a slope of 1, we see that yes, it does pass through negative 4, which it should, because that was the y-intercept. Okay. And then obviously if I had this on graph paper, it would look much better, and we would see that our lines would never meet because they're parallel. Okay. All right, let me do one more that's a little bit more complex. Not that much more. right? But it takes a little bit more work, okay? And then you're gonna finish these notes. You're gonna work on these notes with each other. And then we got some classwork to do. So hopefully we can get everything done so that you don't have homework, okay? But make sure you finish the classwork. So I'd like to do a problem on the back side to show you how it can get a little bit more complex. So I'm looking at number 5 on the back. It says, write an equation, so it's same directions, in slope-intercept form for the line that passes through the given point. So in this case, it's 4, -6, and it's parallel to this line. Now, why is this a little bit more complex? Well, I can't just look at this equation and find the slope because it's not in that slope-intercept form. So the first step would be to figure out what the slope of this line is. So slope of given line. Okay, what is the slope? Well, we need to move it around a little bit. Alright, so we've got to bring the x over to the other side. I'm going to put a 1 in front of the x, if you don't mind, just so that I get the coefficient. But I'm not done yet, right? Because the slope can't be seen unless y is by itself. So I need to divide by 2. And I'm going to pull it over here so you can see it. I get y equals -1/2 x plus 5/2. Okay. Now, I really don't care what the y-intercept is of this line. Doesn't really matter to me. What I really care about is what the slope is. Because this slope right here is what I'll use to find the slope of my line with that point. Okay? I wanted a line that's parallel to this line, so I just need its slope, and now I'm going to take this slope and use it to find an equation. Okay, so step 2, once again, we're back to a review problem, right? This is a problem just like we did in section 3, where if we know what the slope is, and we know what the point is, we're going to start with point slope, and we're going to plug in y minus the -6 would become +6 equals the slope times x minus the x, which is 4. And then what we're going to do is we're going to take that equation and distribute it. Okay, I'm just going to switch colors here. Distribute that. So we have y plus 6 equals -1/2 x plus 2. Right? Negative times a negative is a positive. Half of 4 is 2. And now we just need to bring this plus 6 over to the other side. So we get y equals -1/2 x minus 4. Okay, again, y equals -1/2 x minus 4 would be the answer. Okay, and so really, if you think about it, it's just one more step. Figuring out what the slope is of the line they give you, you're going to use that slope in your new equation. Okay, so please take some time to do some practice, and I hope you all have a great day.